In June 1993, the Queen of the Netherlands opened a container terminal in Rotterdam that had almost nobody working in it. Driverless vehicles carried boxes along the quay. Cranes stacked them in the yard with no operator aboard. It had taken 5 years to build. It was the first terminal of its kind anywhere in the world, and everyone who saw it understood they were looking at how ports would work from then on. 33 years later, roughly 4% of the world's container terminals are automated. That is not a story about slow adoption. When McKinsey surveyed the industry about what automation had actually delivered, operators reported that operating costs had fallen, and that productivity had fallen with them, by somewhere between 7 and 15%. The number that matters most in a container port is moves per hour, how many boxes a crane can shift between the ship and the quay. At fully automated terminals, it averages in the low 20s. At many conventional terminals, the ones with people sitting in the cabs, it runs in the high 30s. The robot port is about a third slower than the human one. And the reason has almost nothing to do with the software. Rotterdam built that terminal to hold on to a customer. Sealand was the American line that had effectively invented container shipping, and by the late 1980s, it was ECT's largest account. Its contract was expiring and half the ports in Europe were trying to take it. ECT chose not to compete on price. Instead, it proposed building Sealand, a terminal where the machines moved the containers themselves, drawing on automation work its own engineers have been developing through that decade. Sealand agreed just before Christmas 1987. The contract was signed the following April, and the terminal opened 5 years later. The technology worked, and by the end of the 20th century, the total number of automated container terminals anywhere in the world was 2. Adoption did eventually come. By the early 2020s, there were around 60 of them, with roughly $10 billion invested. That is still about 4 terminals in every 100. 3 decades after the thing had been proven to function. What held it back was what happened when operators measured the results. In 2017, McKinsey surveyed more than 40 senior figures across ports, equipment suppliers, and shipping lines. The expectation in the industry was that automation should cut operating costs by 25 to 55% and raise productivity by 10 to 35. The survey found something different. Operating costs had fallen, but by 15 to 35%, the lower half of what was hoped for, and productivity had not risen at all. It had dropped by 7 to 15%. That survey is now nearly a decade old, which would matter if the finding had aged badly. It hasn't. A review of the academic literature published in 2024 concluded there is still no clear evidence that automated terminals outperform conventional ones on handling rates, cycle times, or how long ships spend alongside. Understanding why a productivity drop outweighs a cost saving means knowing what a port actually sells. And it isn't storage. It's speed. The most expensive object in the equation is the ship, and a ship alongside a quay is a ship earning nothing. So the number the industry watches is moves per hour, how many containers a single crane can shift between the vessel and the shore in 60 minutes. Take a large container ship needing 8,000 moves, worked by 6 cranes. At 30 moves an hour, she is finished in about 44 hours. At 22, the same ship takes over 60. That is nearly a full extra day alongside. On every single call, the terminal has saved on wages and its customer is paying for the difference in charter hire, fuel, and every downstream connection that ship was booked to make. So an automated terminal can genuinely cut its costs and still be the more expensive place to send a ship. Which is the question the rest of this comes down to. 33 years on, with 60 terminals built and $10 billion spent, what is it the machines still cannot do? It comes down to one machine, the crane at the water's edge. Behind it, automation works well. Stacking cranes in the yard run unattended and have done for years. Almost every stacking crane ordered today comes with automation built in. The vehicles shuttling boxes between yard and quay drive themselves. Gates read container numbers automatically. The ship-to-shore crane is the exception, and 33 years of engineering has moved the operator out of the cab without removing them from the job. Systems for a fully automatic lift cycle exist and are sold commercially. But human oversight remains a regulatory and safety requirement at nearly every major terminal, and quayside work still depends heavily on someone intervening. The reason starts with what the lift actually is. A ship-to-shore crane picks a loaded container weighing up to 30 tons off a vessel and sets it down within a few centimeters of where it needs to be. The box hangs from cables, which makes it a pendulum. It is being lifted from a ship that is floating and whose trim shifts as weight comes off her. And all of it happens in open air on a coastline where wind is a working condition rather than an occasional inconvenience. An operator in the cab manages that swing continuously, and part of how they do it is not visual. Sitting up there, they can feel the wind. The OECD's transport research arm, looking at why remote crane productivity has disappointed, points directly at this. An operator in a control room can see the container but has no sense of what the air is doing to it. And slowing down is the only safe response to information you no longer have. The industry does not entirely agree. Crane manufacturers argue the reverse. Ships have grown, cranes have grown with them, and the distance from cab to container is now beyond what the eye judges well. Operators at a remote-controlled terminal in Sweden report that multiple camera angles show them more than they could see from the cab. Both may be true. Cameras may beat eyes on the largest cranes and still lose to someone sitting in the weather. The yard has none of these problems. A stacking crane works inside a fenced block on level ground, moving boxes short distances between fixed positions a computer already knows. Nothing is floating, nothing arrives unannounced, and the lifts are short enough that swing barely develops. That is a warehouse problem, and warehouses automate extremely well, except the yard is not entirely solved either. And the reason is instructive. When something goes wrong in a conventional terminal, a container in the wrong slot, a damaged box, a truck at the wrong gate, a person notices and works around it, and the problem stays where it started. An automated terminal cannot do that. It has no capacity to improvise, so a single fault propagates down the chain until someone stops the line and resolves it by hand. McKinsey found these exceptions to be the greatest single obstacle to raising productivity in automated ports. And more than 60% of the operators surveyed said a heavy exception load usually meant the same thing. The terminal had automated a messy manual process instead of simplifying it first. So the industry automated the parts of a port that behave like a warehouse, and those parts still stumble whenever reality fails to follow the script. The part that behaves like seamanship it has barely touched at all, and that is the part which decides how long the ship stays. None of which means the terminals were a mistake. Automation delivers things a moves per hour figure does not capture. McKinsey's respondents reported that safety improves, disruptions caused by shift changes fall away almost entirely, and performance becomes predictable in a way human operations never quite manage. The same rate at 4 in the morning as at 10 every day, regardless of who came in. Some operators report far more than that. The partners in Qingdao's fully automated terminal, which opened in 2017 as Asia's first, say it cut labor costs by 70%. The terminal can work at night in darkness because its cranes locate containers using laser scanners rather than light. That claim sits awkwardly against everything already established, and the discrepancy is worth being straight about. The McKinsey figures come from a survey of more than 40 practitioners across many terminals and equipment suppliers, reporting what automation delivered against what it promised. The Qingdao figures come from one of the terminal's own commercial partners without a stated baseline for comparison. Both may be accurate. They are not the same kind of evidence, and the wider studies have consistently failed to find the gains that individual operators announce. What is not disputed is the cost of finding out. To justify the capital, McKinsey calculated that a newly built automated terminal would need operating expenses 25% below a conventional one, or productivity 30% higher while operating costs fell by 10. Neither test is being passed. Return on invested capital at some automated ports has come in as much as a full percentage point below the sector norm of around 8%, which on assets of this size is a serious shortfall. Around $10 billion has gone into port automation, and 3 decades in, whether it has paid for itself remains an open question, which is where the argument stopped being technical. In October 2024, 45,000 dock workers walked out of container terminals along the American East and Gulf coasts, from Maine to Texas. The strike lasted 3 days and closed around 36 ports. Wages were settled quickly enough, 62% over 6 years. The issue that nearly restarted the strike 3 months later, and that had caused the union to walk out of negotiations in November, was automation. The International Longshoremen's Association was not seeking limits. It wanted a prohibition covering full automation and semi-automation alike, which in practice meant the remote-operated cranes and automated stacking cranes used across most of the rest of the world. The employers wanted the freedom to install them. The union's position was that any equipment replacing a historical work function eliminated a job. The union won. The contract, ratified in February 2025 by almost 99% of the membership, runs to September 2030 and contains what the ILA calls ironclad protections against automation and semi-automation. There is an obvious way to read that: a union defending jobs against technology in the largest port system in the Western world, and winning. There is also what the industry's own numbers say: automated terminals measure less productive than conventional ones. Their operating savings fall short of the level that would justify the capital. returns run below the sector norm. And after 33 years, 4% of the world's terminals have adopted the technology. The dock workers were protecting their jobs. On the available evidence, they were not slowing their ports down to do it. Underneath all of this sits an assumption that automation eventually wins. Give it enough iterations and the machine does the job better and cheaper than the person. And the only real question is when. Factories are where that assumption comes from, and factories are unusually good ground for it. A factory decides what comes through its doors, in what order, at what rate, indoors. A port decides almost none of that. It takes whatever arrives, whenever it arrives, in whatever weather, from customers who reroute ships mid-voyage and stow them in ways the terminal discovers on the day. Automation is at its strongest where inputs are controlled and a port's inputs are controlled by other people. Which may be why, when the OECD's transport researchers examined what predicts a container port's performance, the equipment came second. How a port is organized mattered more, along with what it specializes in, its size, and its location. Automation was one input among those, and not the dominant one. That is what explains the 4%. None of this means the quay crane is unsolvable. The systems exist, they are improving, and the constraint is precisely identified. A container on cables is a pendulum, the ship beneath it is floating, and the wind is always there. But 33 years after Rotterdam, with around 60 terminals built and $10 billion committed, the research has not found the productivity advantage that was expected. Individual operators report gains. The studies, looking across many terminals, keep failing to confirm them, which matters beyond the industry because berth time is a cost that travels. A ship spending an extra day alongside is a ship burning charter hire and missing connections, and that lands in freight rates and eventually in the price of goods. It also means the largest port system in the Western world has now committed to staying manual until at least 2030. Not because the technology was unavailable, because when the people who move the boxes and the people who buy the machines both looked at the numbers, only one of them was certain what those numbers proved.